Okay, so in this lesson, we're going to talk about binomial expansion in ascending and descending powers of x. Okay, so I've taken the liberty to copy the Maclaurin expansion, okay, from the MF26. Okay, so this is also freely available on the web. Okay, you can actually find this expansion formula. All right, now we're going to use this for reference, but right now we're going to talk about a little bit more of the understanding about ascending and descending by giving you some examples, okay? So sometimes in the exams, they might actually ask you to expand a binomial expression, okay? And they want the ascending powers of x. What this means is that you would see that you would have the x going ascending powers like this, right? X squared, x cubed, so on and so forth. So that is what it meant by ascending powers. However, the question will differ slightly. What you notice over here in our MF26 formula, okay, given in the Maclaurin expansion, it is actually 1 plus x to the power n. You notice that the constant starts with a 1, okay? However, in your question, you may get something like this, okay? So let's take a look at an example. Say, okay, you know what? Let's change the color, okay? So we'll use blue instead for the example, right? Example, okay. So let's say you are given a question that looks like this: 4 plus 3x, okay, to the power of, say, minus 1, all right? And you are asked to expand this in ascending powers of x. Now, the first thing is that you notice this is 4, okay? So it is actually different because what we really want, in order to be able to use this, this formula that's given, we need to make this 4. And that's actually, we need to make this 4 to 1, okay? And to do that is actually quite simple. All you need to do is to pull out the 4. So let's do this step by step, all right? So I'm going to put the square brackets like this, okay? And the minus 1 on the outside. So these round brackets are now the square brackets, okay? Because we're going to introduce a set of new brackets inside. So what we'll do is we'll pull out the 4, okay? We'll pull out the 4. So in that case, we have a 4 bracket 1 plus 3/4 x, and then we'll close the bracket, okay? So didn't change anything on the outside, okay? You will just notice all I did is that I pull out a 4. So if you multiply that in, you'll realize that it give you a 4 back, and then 4 times 3/4 will give you the 3x back, okay? All right, now next up, what we'll do is that we'll expand this, okay, using the laws of indices. So the 4, when we expand, right, and get rid of the square brackets, we have 4 to the power of minus 1, okay? So for some of you, if you prefer, you can go ahead and write it as 1 over 4. And that's exactly 4 to the power of minus 1, right? Now, next up, we will also have this, and that will be 1 plus 3/4 x to the power of minus 1. Okay, so this is exactly equal to this. Now, as you can see, for the second part, this is exactly like this, format-wise. All right, we have the 1, and then we have the value at the back, which is x. In the previous lessons, we talked about how to use the different Maclaurin expansion from your MF26. So in this one, we'll just look at binomial, but the way of using them is very, very similar. Okay, so in that case, what we'll do is that we will replace all the x in our formula with this x, 3/4 x, okay? So let's go ahead and expand this, all right? Now, I should have put ascending over here. So this one would be example, okay? So it's easier to see. This will be ascending powers, okay? Let's just put ASCE, okay, we'll spell it out, ascending, dot, dot. So that's the question over here, all right? Now we're going to go ahead and expand this. Now we were going to keep the 1/4 in, so it's always easy to just leave it outside first and then just expand this guy, right? So we'll put a square bracket and have all the terms that we have expanded inside. Now it goes off with 1, okay, it starts off with 1, and then after that we have an n, okay? This n corresponds to this n over here, all right? So in that case, our n value is minus 1. So we're going to change my n to minus 1. And then we have an x, which is this guy, right? So in our case over here, it's 3/4 x, okay? Next up, we're going to move on to the second one, which is plus n minus 1. So that is going to be minus 1, which is the value of n, and then minus 1, right? So that gives us minus 2, okay? So that's that. And then 2 factorial. followed by x squared. So in that case, we'll put in 3/4 x whole thing squared. Okay, let's do one more. Let's suppose that the question actually asks us to expand this in ascending powers of x up to and including x cubed. All right, so we have to do one more in that case, and this is from here. We have -1, -2, because it's -1, -1, and then -1, -2 gives us -3 over 3 factorial, and then 3/4 x whole thing cubed. Okay, so we're gonna add in the plus dot dot dot, all right, and then we close that off. Now, before I continue to the next step, I just want to mention that in your MF26, they only gave you the first 3 terms, and then they'll put the plus dot dot dot. Okay, if you are holding an MF26, you will know. Okay, and then after that, they actually had a general formula. Okay, so I leave that to you. You can use the MF26, but to look at the general formula, okay, I'm not showing it here. Now, the thing I want to mention is this. What if you only have these, right? 1, 2, 3, and then you don't have this. How do you actually come out on your own? Now, you could use the general formula, but I think the faster way is to just remember the pattern, okay, for the expansion of a binomial, all right? What you notice is over here, this is actually n over 1 factorial. We don't write the 1 factorial because it's just division by 1, right? So that's just n. Now, take a look at the second one is n times n minus 1. So you have two terms, and then divide by 2 factorial. So you follow the same pattern. So when you go on to this guy, which is x cubed, all right, for the x cubed, the coefficient is simply going to be, you start off with n, and each time you decrease it by 1. So you will have 3 factors that corresponds to the x cubed term. So you have n, n minus 1, n minus 2. See the pattern? Okay? And then you divide it by 3 factorial. So if I were to ask you to give me, in general form for x to the power of, say, 5, okay, I'm going to skip x to the power 4 and just go straight to x to the power 5, you would tell me that it is n, bracket n minus 1, n minus 2, n minus 3, and then n minus 4. Okay, I ran out of space, so that will be the x to the power 5. Okay, and then we're going to divide that by 5 factorial. Okay, so you go and count 1, 2, 3, 4, 5. 5 factors in the numerator. Okay, each one is 1 less than the previous, and then 5 factorial, that corresponds to x to the power 5. Okay, so it's actually quite simple. Once you remember this pattern, you can come out with as many terms as you want. Okay, based on the pattern. Okay, now we're going to go ahead and finish this up. Okay, so let's go ahead and simplify all this first before we multiply the 1/4 in. So we have 1 over 4, okay, 1, and then this one is going to give us minus 3 over 4x, okay. Then after that, for this guy, okay, it's got a negative become positive, and then if you were to take 2 divided by 2 factorial, it's just going to give you 1, right? So it happens to be plus, okay, in this case. And then we're going to square this. That's going to be 9 over 16x squared. Okay? Next up, we move on to this. Then we have 3 minuses. Okay? So that will give us negative. And then when you take 1 times 2 times 3, the whole thing divided by 3 factorial is just going to cancel out again and give you 1. Okay? So in that case, what we're left with is just this guy. Okay? So that will be 3 cubed. So that's 27. And 4 cubed is 64, okay? X cubed plus dot dot dot. Now, we're ready to finish this, okay, by multiplying the 1/4 inside. So I'm just gonna squeeze in over at the back here. We've got some space left, so it's 1/4. Then 1/4 times 3/4 gives me minus 4 squared, that is going to be 16x, okay? Then this one, so 4 times 16, okay, that would give me 64, right? 64, 9x squared. And then lastly, the last one is this one, which is minus 27, okay, 64 times 4, 4, 4, 16, then 6, 4, 24, 25 is 256, x cubed. Alright, so not to forget that we have the plus dot dot dot, so I'm gonna like squeeze in here, so we got a plus dot dot dot. Okay, I hope you can see that. It's at the edge of my board. Alright, so there you have it. This is the answer. Okay, so this is how we expand a binomial, okay, in ascending powers of x. All right? Okay? Now, sometimes they might actually ask you to do to expand this in descending powers of x. So when you do that, you would have to follow what I'm going to show you right here. Okay, so in descending power of x, we are going to do it slightly differently. All right. Now again, let's say we have the same question, 4 plus 3x to the power of minus 1. And this time round, they want us to expand in descending powers of x up to and including x cubed. Okay. So in that case, when we were to expand this, now, okay, let's start over again. We will introduce a square bracket, which is now which was originally the round brackets, okay, and then the minus 1 on the outside. But this time round, instead of pulling out a 4, what we'll pull out is the 3x, okay? So when we pull out the 3x, we'll have 3x on the outside, and then after that, this term will become 1, right? When we pull out the 3x, the second term here will become 1, right? And so instead of writing it in as the second term within the brackets, okay, within the square round brackets, I'm going to put it inside here. So this 3x times 1 is this guy. And then after that, we pull out 3x from here, we are going to have a 4 over 3x. Okay? Now if you multiply this back in, you'll get this. 3x times 1 is 3x. 3x times 4 over 3x is 4. Okay? So it's actually the same, but I kind of switched the position around as well. Why? So that now this guy have the same format as this guy, right? We have the 1 in front. Okay, let's go ahead and multiply, or rather apply our indices law so that we expand this and get rid of the square brackets. So in that case, now we have 1 over 3x, okay? And that's for the first term. And the second term, it's going to be 1 plus 4 over 3x to the power of minus 1. Okay? So now we can use the binomial expression we have over here on our formula sheet and expand this. Okay? Now let's go ahead and do that. So 1 over 3x, okay, let's introduce a square brackets and we're going to expand this inside. So let's start off with this again. So this time round, what we need to replace for x would be 4 over 3x, okay? So 1, okay, doesn't change, and then plus n, so plus minus 1, our n is minus 1, and then x, okay, over here, so in that case it's this guy, which is 4 over 3x, alright? Then next up, we move on to the second one, so it's plus minus 1 times minus 2 over 2 factorial. Then you square this, so it's 4 over 3x, whole thing square. Then plus, okay, again one more, minus 1, minus 2, minus 3 over 3 factorial, bracket 4 over 3x to the power of 3 plus dot dot dot. Okay, now let's move on. So 1 over 3x, let's simplify the stuff in the square brackets. We have 1 minus 4 over 3x, okay, this guy. And then we have negative, negative become positive. So 2 over 2 is still 1. We're going to square this, that's going to give us 16 over 9 x squared, okay? Let me write this a little bit nicely. I'm going to centralize the denominator a little bit. So this is 16, then this is 9x squared. Alright? Okay, next up we have this guy. Again, negative, negative, negative gives me negative. And then this whole term is just 1. And then over here we're going to cube everybody. So 4 cubed is 64 over this, which is 27x cubed. Right? Plus dot dot dot. Okay? So now we're going to multiply this guy in. Okay, and you realize what happens now is that when you multiply the 1 over 3x inside here, okay, the last term is going to give you x to the power of minus 4, okay? So I just realized that in my question I said let's expand this in descending order up to and including x cubed. I should have said up to and including x to the power of minus 3, okay? So let's make that correction there, all right? Now, in that case, we're going to drop this term. This is not necessary as a result, okay? But that's okay since we have done it. Let's not change it. Now we're going to multiply all this in. So we have 1 over 3x, okay? And then after that, the next one would be minus 4 over 339. So that's 4 over 9x squared. And then we have a plus 16 over 9 times 3, which is 27x cubed. Okay? And like I said, let's omit anything that is lower, x to the power of minus 4 and below. Okay, we'll omit those, so we'll just stop here, and then we'll have a plus dot dot dot. All right, so that will be your answer. And as you can see, if we were to make x to be in the numerator, you will notice that this is essentially 1/3 x to the power minus 1 minus 49. Okay, and then you move the x squared to the numerator, it will become x to the power minus 2. And then this guy is 16 over 27 x to the power minus 3, so on and so forth. The reason I wrote this in red, okay, this don't have to be a solution, just in case you're wondering, is I want to show you clearly that this, as you can see, is the descending powers of x, okay? X minus 1, minus 2, minus 3. So, you know, in this pattern is actually descending powers, okay? So that's what the question wants, all right? And that's how you do it, okay? So before we end the lesson, let's just summarize this, okay? So if you are asked to expand in ascending powers of x, okay, what you will do is that you will pull out the first term, okay? Pull out the first term. So that will be your step number 1, okay, as indicated here. That's what we did, right? And then after that, your step number 2, okay, let's write it over here because it is the same for both ascending and descending. So I'm just going to write it over here. Step number 2 is to expand and simplify, right? Expand and simplify, okay, right, using the expression or formula, okay, from your formula sheet, okay, from your formula sheet, which is the MF26. Now, for the part that you are going to be doing the descending, okay, instead for step number 1, right, for step number 1, you would pull out the second term, okay, pull out the second term. I'm just going to write it in short form, second term. All right, so that's what we did over here, okay? And then again, we're going to do step 2, which is to go ahead and expand this one using the formula given. All right, I hope that makes sense. So that's how you do the binomial expansion for ascending and descending, okay, powers of x.